Our final type of problem is going to be an inelastic collision. This happens when two objects stick together, as shown in our example problem, where we have a dry cleaner throwing a 22-kilogram bag of laundry onto a stationary cart. So before, we have our bag of laundry, and it's getting tossed, and it lands on a stationary cart. Okay, our cart is 9 kilograms. Our laundry is 22 kilograms. This has an initial velocity, and this velocity is currently 0 meters per second. After the bag lands on the cart, the two will move together as one. So we will see that the bag of laundry will sit on top of the cart and move together at a speed of 3 meters per second. So let's set this up now that we have it drawn. Again, as with the last two problems, we are going to do our total momentum before having to equal our total momentum after. So momentum of 1 initially plus the momentum of 2 initially has to equal the momentum of 1 final plus the momentum of 2 final. In this case, we're going to see a slight change. Since our two objects move together, we know that they both have to have exactly the same final velocity. While it's not as pertinent in this example, in some examples it will be more helpful to write this as follows. Mass 1 times initial velocity plus mass 2 times initial velocity equals mass 1 plus mass 2 times the final overall velocity. So let's plug in our numbers and see where this leads us. Initially, our mass was 22 kg, and we want to solve for its initial velocity, so we'll leave that as follows. Then we're going to add that to mass 2, 9 kg, times 0, equaling 22 kg plus our 9 kg, that's our total mass now that they stick together, times a final velocity of 3 meters per second. When we calculate that out, we find over here we had a total momentum of 93 kilogram meters per second equal to 22 kilograms times initial velocity plus 0 momentum. So our initial velocity of our laundry bag has to equal 93 kilogram meters per second divided by 22 kilograms. Therefore, our initial velocity will equal 4.23 meters per second to the right because our final example showed that together they move to the right.